was shattering. I thought the fundamental theorem of algebra should say more than this. I think I might have some more secret stuff here. Oh. You should. You don't really have to write more importantly, I guess, but that's just my part.
Wow. I already wrote 4.
Then write it. This is the actual theorem. This is like in addition to the theorem, but I think this part is more important than the actual theorem. Every complex polynomial of degree n will have exactly n complex zeros. Now that's including imaginary, right? Because complex can be imaginary. So that's why in what we did last week, sometimes we didn't find all the zeros because we didn't do the imaginary. But whatever the degree is, you will have that many zeros. So a degree 5 will have 5 total zeros. A degree 3 will have 3 total zeros. And I put including repeating zeros because sometimes we forget about those. Like if you have a multiplicity of 2, then that 0 counts 2 times. So eventually we are going to do what we did last week where we solve all of them, but there's other stuff in this section that I thought we would work on today, just kind of working with some imaginary zeros before we get into the stuff where we just find all the zeros. Okay? Maybe it just will rain today. That's what I'm hoping. It's just all wrong and it just rains. And just rain. Supposed to just change the rain eventually. Thunderstorms. It's going to be like flooding. There's so much snow and then it's going to rain. It's going to be so much water.
I'm just sick of it like almost being gone and then we just get more stuff.
We haven't had almost gone in forever. Like I forget what the grass looks like. It's been so long. Alright, this is the last writing thing, I think. I wrote these on Friday before mass chaos ensued. Conjugate pairs theorem. It says, if f of x is a polynomial function with real coefficients, if a plus bi is a 0, then a minus bi is also a 0. There you go, kids. You're going to get out early.
I do have a website.
Or when this class is over, either one would work. Try and dear.
I have a question about the math.
Yes.
If we measure like by our examples, do we have to write everything down? Because like I've noticed whenever I go back to the notes, I never look at what I write down, like word wise. Like if there's words.
I don't care, dear. Whatever you want to do. I don't check your notes, so you don't even have to write notes down, right? They're for your
No,
benefit.
I have to write notes down.
So, I hope you know this already, but imaginary zeros always come in pairs. That's all this is saying. If you have one imaginary zero, you always have another imaginary zero. Because if not, you would have I written out in your polynomial, right? And you have to have I and I together, because what does I squared make? Negative 1. So that's why imaginary zeros come in pairs. So if 1 is there, its conjugate, or usually its opposite, is there. Part of your homework today is that simple. They give you some zeros, and they say find the other zeros. And they're just always the other conjugate, like the rest of the imaginary zeros. So, finally, let's do an example. What? I don't have time for this. So, a function of degree 5 has zeros 1, 5i, and 1 plus I. Find the remaining zeros. So, x equals 1, x equals 5i, and x equals 1 plus I are the zeros that they gave me. And they're telling me it's degree 5, which means how many more zeros should I have? And if I have 5i, what other imaginary zero do I have to have? If it's just an I, you just always take its opposite. If I have 1 plus I need the conjugate of that also. And the conjugate, when there's addition, you leave the first one alone, but you change the sign of the middle one, right? So what other imaginary zero do I have to have? That's easy, right? And you don't have to work anything out. You just give me those zeros. No, this is not all we're doing. We're actually getting to something.
Why would we not do the negative 1?
Because this is not imaginary. Real zeros don't come in pairs, only imaginary zeros. And we can check 1, 2, 3, 4, 5. We know we have all the zeros. Okay?
Wait, so we go to the negative 1?
only imaginary zeros come in pairs, right? Just because 1's a 0 doesn't mean negative 1's a 0.
So it could be like 3, but you wouldn't use it again if it wasn't 3i.
Because imaginary zeros have to come in pairs because that's the only way you get the I to go away. Real zeros don't have to come in pairs. Now what about this one? This one we're going to have a little bit more work to do. It says, use the given 0 to find the remaining zeros. And so, they're not just saying list them all, and we couldn't just list them all by looking at this anyway, because how many zeros is this function going to have? 3. We know 2 of them, because if 2i is a 0, what else is going to be a 0? Negative 2i. But we have to find the third one, and it could be real. Well, it can't be non-real because they have to come in pairs. But Vaughn says, why don't we synthetically divide 2i out? Does that sound like a good idea? It does. It's kind of weird with i's. I just want to forewarn you, it's going to get a little messy. But in the end, it's going to work out. So since 2i is a 0, just like if 2 was a 0, we can synthetically divide 2i out. 1, negative 4, 4, negative 16. It's going to, we have to use 2i because it's the actual 0, right? It's not like x plus 2, right, where you just pull off a negative 2. Right, like this is already the 0. Like they're telling you the 0 is x equals 2i. So we're going to have to divide this out, and we're going to have i's in this problem. So you got to bear with me here, right? There's some good math here. So I'm going to bring 1 down. Are you with me to this point or not? Tell me if you need me to wait. And when I take 1 times 2i, I'm going to get 2i right here, yes? Can I take negative 4 plus 2i? No, like I'm going to write that as negative 4 plus 2i. You need bigger spaces, yes. And I kind of do some side work on this one because now I got to take this times this, yes? So off to the side here, I'm going to just do my work. 2i times negative 4 plus 2i. Trevor, remember doing this in pre-cal? In September, we did this.
So since I've done this pre-cal,
you still have to do it.
go ahead and give me like
It's on your unit. There's one like this on your unit test, so we got to do it. So I'm going to take this times this, and I'm going to get negative 8i. And 2i times 2i is 4i squared.
Negative 4.
So that's really negative 8i minus 4. That's what's going to go right here. Negative 8i minus 4. There's kind of 2 ways to do this, and I always do it like this way, but I don't know if I should even show you the other way. I think I should just make you do this. And then what happens? 4 minus 4 is 0, right? So I'm just going to get negative 8i. We already know this is a 0. So if you don't get this to be 16 for a remainder of 0, then you know you've done your math wrong because they're telling us it works. So when I take negative 8i times 2i, does that work? Because I get negative 16i squared, which makes positive 16, which gives me a remainder of 0. Yes? Not done yet. What else is a 0 of this problem? So now I have to divide out negative 2i. But the good news is, now it's going to work out. We shouldn't have any i's left after this. Because, first of all, we don't know how to deal with stuff with i's left over in it. And it goes back to that complex conjugate theorem. If 2i is a 0, don't we know that negative 2i is also a 0? Yes? So every time if they give you one imaginary 0, divide it out, and then divide out its conjugate. This should work out much better now. This is like the home stretch. The worst part is the first one. What is 1 times negative 2i? And do the i's cancel out? And I bring down my negative 4. What's negative 4 times negative 2i?
Negative 8i. 0.
That's what should happen. So what were we left with? This was x to the third, so we divided out once, that would be x squared. We divide this out, it's just x minus 4 is what I'm left with.
So x equals 4.
So set it equal to 0, and x equals 4. So find all the zeros. It says find the remaining, but I'm just going to write x equals plus or minus 2i, and x equals 4. Not the worst thing in the whole world, right?
For now.
So I could do one more step to make it a little harder. Ready?
I forget this is what you're talking about. What else? I just want to cry.
Same directions. We can. It's just going to get a little messy. Leave some room here, kids. We're going to have to foil. So I don't know if you want to do your work to the side or you want to do it all together, but we're going to have to write out more. So same directions, find the remaining zeros, only look what's different. And this is how it gets more difficult. And I can tell you that there's one on your unit test like this, where the addition over here. If they give me 3 minus 2i, I'm going to divide it out, and then I'm going to have to divide out its conjugate, but it's going to get a little bit uglier. So I'm going to put 3 minus 2i here, and I'm going to bring down all my numbers, 1, negative 6, 11, 12, negative 26. And this is where I do my work to the side, but you're going to have to FOIL this out at some point and do a little bit of work. What should happen is we should get a remainder of 0. If we don't, then we know we've done some arithmetic wrong, and then you just want to wipe your paper up and throw it up. Yeah. Trust me, I've done it. But the first step's easy, right? Bring down the 1, and 1 times this is going to be 3 minus 2i. And then combine this stuff. You can combine negative 6 plus 3 is negative 3, and then you just bring down the minus 2i. I'm just adding these together. Negative 6 plus 3 is negative 3.
Oh, right.
And now I have to FOIL this with this, right? Like I have to take 3 minus 2i times negative 3 minus 2i, and you got to FOIL that. Oh, we're making me do math. You get out of 2 at classes today, so you can make it up by doing this right now. All your classes are easy besides mine. So I get negative 9 minus 6i plus 6i plus 4i squared. And so that's really negative 4. Those actually cancel out. So that's just negative 13. Do you agree with that?
Yes.
That's weird. So that gives me negative 2. Yeah? And now I'm going to FOIL that. So 3 times negative 2 is negative 6. And negative 2i times negative 2 is positive 4i. Does it work or not work? Should work. I copied out of the book. It's got to work, right? Unless I copied something wrong. So this is 6 plus 4i, and now we got to FOIL that, right? Oh, okay. So now I'm going to do 3 minus 2i times 6 plus 4i, and I'm going to get 18 plus 12i minus 12i minus 8i squared, which is going to become plus 8. Some people just have blind faith that it works and automatically put a 26 in there. I like to actually check it. But it works, which means I get a remainder of 0. That's not that much fun, but it's not impossible to do. You would do the conjugate. The conjugate, you only change the sign in the middle, right? So if this is 3 minus 2i, now we're going to do 3 plus 2i. And what should happen is every step of the way, the I should cancel out now. Because they come in pairs, and once you divide out the second one, it should work out. The fun part for me is grading these when they don't work out and trying to figure out where you went wrong. So that's just 3 plus 2i. You get 0 there? So So then it is very convenient. I honestly just picked it out of the book. Like, I didn't even know the answer to it yet. So this is negative 2. And then that's negative 6 minus 4i, which is 0, which is my remainder. What's my exponent left on this one? This is x to the 4th, so we divided out once. It was x cubed. Divided out again. This would be x squared plus 0x minus 2. Now your job is to solve that. And what would I do to solve that?
I'm gonna add 2 over and then square root it.
So I'm going to get x equals plus or minus the square root of 2. And I like to go ahead and put the answers, like they gave me 3 minus 2i, but I'm going to say 3 plus or minus 2i. That was a 4th degree equation, and we got 4 answers, 2 imaginary and 2 real. Notice that your PRZs would not have helped you on this because the square root of 2 is not a rational number, so no PRZs would have worked on this problem. Just exciting, right?
So basically, we can just put like PRG.
Well, not always. If they give, this one's easy because they give you one, right? As long as they give you one, you don't need PRZs. If they don't give you one, then we'll talk about that. I don't know what else I have. Let's. Homework. No, not on these today. Not today. I believe 9 through 15 are like our first example, which are the easy one. Like they give you the zeros and they just ask you what's left, and it's just the conjugates. But then 24, 27, and 28 are like our last 2 examples where you actually have to synthetically divide it out, and they do take a little bit of time. You have a ton of time left in here since we didn't have homework to go over. So work on that. I'm going to work on passing back some papers because I seem to have like 8 million. And if you need to go to the office to figure out what you're doing, go ahead and go to the office. Yeah, I'll be official.